Okay, let's get back into chapter 6. Okay, remember last time we started in chapter 6 on Friday? A lot of people were absent in here. Okay. So we started into this chapter on alkyl halides. So let's go ahead and pick up on that topic. Let's look at different types of alkyl halides. Okay. There's some alkyl halides, and we want to refer to them as different types. This will be very similar to the types of carbon and hydrogen we can have. Okay. So if you look here, what kind of carbon is attached to this chlorine here? Is it a primary or secondary? So we would say this is a secondary alkyl chloride. Okay. What kind of bromide is this? Primary. Okay. So that would be a primary alkyl bromide. And the last one would be tertiary. That'd be a tertiary alkyl iodide. Okay, so pretty straightforward stuff. Okay, so we'll be using that nomenclature throughout the lecture today. Let's look at something else here. Let's suppose we had a molecule like this. And one like that. No eating in class. I like to hear those crinkles. Okay, so here you have what? Two halogens, so these would be dichlorides. Dihalides. And here we classify these two. Okay, the one where I got both of the halogens on the same carbon, this is what's called a geminal dihalide, or in this case, a geminal dichloride. All right, let's go on now. Look at how to make alkyl halides. Okay. Let's scoot over a little bit. Here, just scoot over. How to make alkyl halides. Okay, the first way that we have learned was by way of free radical reactions. Okay. So in free radical reactions, for example, if we had a reaction like this, okay? And just by station identification, your quiz this week will be on radical reactions, okay? So I didn't give one last week on radical reactions, but this week we will have one on it, okay? And don't think I mentioned as well that they have a quiz every week. I'm going to drop your 2 lowest quizzes, okay, throughout the semester. Okay, so your 2 lowest quizzes, not exams. So you don't get carried away there. Okay, so here, I'm not going to take you through the whole mechanism, but remember that here you get different monochlorinated derivatives. So the chlorine could add there. Could add there. Or it could add in the middle. Okay. So here you end up getting what? A mixture of products. Okay. Okay. In organic chemistry, we don't like mixtures. We like to just get one pure product. Okay. So free radical reactions are not good in order to just get one product. Okay. So we're not going to make alkyl halides using this method here. Okay. So we're going to use another method. Okay. Any questions on that? So let's look at the primary way that we will make these. The primary way we will make alkyl halides is from alcohols. Okay. And what we'll do is break this down to 2 parts, primary and secondary alcohols, and tertiary. Okay. So students always get confused on this to start with. Let's see if you follow as I do this. Let's suppose I wanted to make this secondary alkyl chloride. Okay. Suppose that was my goal. What molecule would I need to start with? I would need an alcohol. Okay. So in other words, pretend in the lab that you didn't have any of this 2-chlorobutane, but you did have this alcohol here that we'll learn how to name later. Okay? So if I had this, I can easily convert to that. And in the lab, I would look for this reagent here, SOCl2, okay, which stands for thionyl chloride. Okay, it has this Lewis structure. Right here, 2 chlorines on this sulfur. Okay? And so this thing turns out to be a very strong chlorinating agent. So the way to remember this reaction, it substitutes a chlorine for the OH. Okay? Some of you have been asking when to start writing these note cards, these index cards. Well, right now's the time. Right now's the time. Okay? So what you can do with these index cards is you could write, for example, this plus this gives you question mark, and on the back of the card, write down the product. Okay? Or another way to make these cards is to write this plus blank gives you this. On the back of the card, you would write SOCl2. Okay. Let's do another example of this. Let's suppose you had this alcohol and reacted with SOCl2. Okay. See what product you would get? Chlorine would what? Substitute for the OH. This time it's a primary, right? Up here was secondary. Okay? So for primary and secondary, I can use this reagent, SOCl2. Okay? If it was tertiary, I can't use SOCl2. For example, suppose I wanted to make this T-butyl chloride, which is tertiary this time, isn't it? Well, I would start with the corresponding alcohol. But I would use a different reagent here. Got it? Because it's tertiary. This only works for primary and secondary. So for the tertiary case, I would use HCl. Okay. In fact, you'll probably do this experiment in the lab later on this semester. Okay, so any questions on the distinction between primary, secondary, and tertiary? Okay. Well, let's look at how to make the other halides. Let's suppose I wanted to make this bromide. What would I start with? The corresponding alcohol. And now I want to put on a bromine. So in this case, I would use this reagent, PBr3, phosphorus tribromide. Okay? So when I want to put on a bromine, I use PBr3. If I want to put on a chlorine, I would have used SOCl2. Okay? And again, this holds for whether it's primary or the secondary case. I'll give you that. Okay. If I had the tertiary case, that's right, I got to use HBl. okay, to get the T-butyl bromide. Okay. Questions on that? Let's look at one more halogen, and that's the iodide. How do we put on the iodide? Well, let's stick with these two molecules. This time what I use is a mixture of phosphorus and iodide. And that mixture will substitute the iodide for the OH. Okay. Same thing down here on this secondary alcohol. I would use the mixture of phosphorus plus iodide. And get iodocyclohexane. But if I wanted the tertiary, I would use what? HI. And that would give me T-butyl iodide. So any questions on how to make these different alkyl halides? Okay? So again, start making these note cards, get in the habit of it. So when you get to 242 and you have jillions of more reactions than now, you'll be in the habit of doing it then. Okay? So if you have questions on how to make the cards, stop by my office and I'll help you make a couple and you can make the rest. Okay, so that's kind of the preliminary stuff of chapter 6, okay? What we're going to get into now is really what's considered the bulk of chapter 6. What we're going to get into are what are called substitution reactions. Okay. And let's begin our journey here by looking at this molecule here. Then I'll just draw partial. And we're going to look at these two atoms that are vicinal to each other, adjacent. So you got a hydrogen and a Cl there. What I'm going to do is take this molecule, whatever it is, and react it with a base. What was the key thing about a base I needed? I needed what? What's the definition of a base? Something that has what? A lone pair. That's something, a lone pair. Okay, so we're going to draw big lone pairs there to remind us what a base is. Okay. Well, when you have this kind of alkyl halide, there are two different reactions that this can undergo. Okay. Okay. One reaction is where I would get this. How would you describe what happened in this reaction? Yeah, that's simple. Yeah, that's simple. You can laugh about it. Okay? Base substituted for the chlorine. Okay? So we'll call this here a substitution reaction. Okay? The base substituted for the chlorine. It was that simple. But there's another reaction this base can do to give you this product here. Where here, you end up forming a double bond. Okay. Anybody know what we call this reaction?
Elimination.
An elimination reaction. Okay, because what we've done, if you take a look, we've eliminated H and Cl. Okay, they're gone, and I formed a pi bond in there to give me a full double bond. Okay. So these are the two reactions we're going to look at in chapter 6. Which one do you think we're going to look at first?
Substitution.
Okay, that's why I wrote that there. You picked up. Okay, so we're going to look at these first because this category here is the most dominant of the reactions. Okay, and then the second half of chapter 6, we'll look at elimination reactions. Okay, so our exam, which will be next Wednesday, is going to go up through substitution. You can leave elimination alone. That'll be on the next exam sometime down the road. Okay? So let's go ahead and start studying substitution reactions. So let's redraw what we had here. And if I look at this molecule here, do we see any dipole moments there? Right here. So when you have a dipole moment, what else can you draw? Partial charges. So I got a delta minus here and a delta plus here. Okay. So if this base was going to do a substitution reaction, where do you think it's going to attack? Where's it going to attack?
Chlorine.
The lone pair, where's it going to attack? What did you say back there?
Chlorine.
Okay, why would you think it's the chlorine? What's the charge on the electron?
Negative.
So why would it be attracted there? Where's it going to be attracted to? Plus. The plus. Got it? forget that electrons are negatively charged. So it's going to be attracted to the plus and kick off that chlorine. This here that we just drew is called what? With these arrows.
Mechanism.
Mechanism. This is the mechanism here. That we want to start becoming familiar with. Pretty simple mechanism. But here, this actually turns out to be one of two possible mechanisms. So we'll make this plural. We'll call this one possible type of mechanism. Let's look at a second possible mechanism. Might say I don't see any, but there is one. So let's redraw the molecule here. Okay. Notice that hydrogen is not doing anything, is it? Troy, no need to draw it, but since we started drawing it, let's keep drawing it. Okay. Another mechanism is, again, I got this dipole moment here. Okay? So that chlorine is pulling on that bond. It's pulling on the bond. In fact, pulling on these electrons so bad that another mechanism is the chlorine can go ahead and leave. We'll see why it leaves or how it leaves later on. But if the chlorine went ahead and left, that carbon would end up getting a positive charge. And the chlorine has left there. And then, what could happen is the base now comes. What's that base going to do here? Attack the positive charge. Okay? And so we would get this kind of molecule. Like that. And so that would be a different mechanism. You may have heard the phrase, the end doesn't justify the means. And again, it doesn't here, because you get two different means to the same end. Okay. This top mechanism is what's called the SN2 mechanism. And this bottom mechanism is called the SN1 mechanism. Okay. So we got two different mechanisms that we need to master. Okay? That's what we're going to spend this whole week doing, is mastering those two and identifying all the characteristics of those two. So we're going to get sick of these two. Hopefully get sick. All right, so we're going to start working with real molecules. Which of these two mechanisms do you think we're going to start looking at first? The SN2. Why do you think we'll look at the SN2? Because it's the more popular. Okay. In fact, most of chemistry is SN2 mechanisms. So if we understand SN2, we'll understand a lot. Okay, the first class of reactions we studied were what? Radical reactions. Now, the big category, substitution. Now the substitution, the SN2s dominate. Okay? So, let's go ahead and go down that road a little bit. Let's start getting in some of the details of the SN2 mechanism. Okay? So let's abbreviate things a little bit. Okay, sometimes we'll use X to stand for halogen. Okay, so we did have chlorine as an example, but and let's have a base that we'll have as B there. Okay, so the mechanism here was the base coming on the other side and kicking off the halogen. And the halogen leaves as X minus. Okay. Well, let's give some terms to this setup here. The base, we're going to start calling the nucleophile. Okay? So the base is the nucleophile from now on. It's the attacker. It's the attacker. The halogen, what is that acting as? The leaving group. Okay, because it's leaving that molecule. Remember that there was a dipole moment here. And so we had some partial charges. Well, the carbon has a partial positive charge. And that's what's called the electrophilic site. The electrophilic site. Why do you think it's called the electrophilic site? What does philic mean? Love. So it loves to have electrons. From where? The nucleophile. Okay? So that's the electrophilic site. This whole molecule is what we call the substrate. Okay, so the substrate is where the reaction is performed. Okay. And you got different parts of the substrate, the electrophilic site and the leaving group. Okay? And we will see later on that we can have other leaving groups besides halogens. But for now, we'll stick with the halogens. But we'll see there's a whole bunch of good leaving groups besides halogens. Okay? So this is our setup for substitution reactions. So if we drew another model of all this stuff, we could maybe draw something like this. Okay. So that in an SN2 mechanism, the nucleophile attacks the substrate, kicking off the leaving group. Okay, or more particular, the nucleophile attacks the electrophilic carbon, kicking off the leaving group. Giving you those products there. So this is what we want to look at for SN2 reactions. Any questions on that setup? Pretty straightforward. Yeah.
Where's the significance of it going like to the back of it?
Yeah, we'll see that through time, but just wanted to introduce you to that.
So it never will attack the front door?
Won't attack the front. Anything else? Okay. So let's go ahead and look at some live examples of this stuff. So here is an example. Note over here that you have a nucleophile, which is CH3O minus, but you'll usually always have a counterion, a metal counterion, and you can just basically ignore that. That's not going to play any part of the reaction. But just like if you add NaCl, okay, salts, okay, you never have a negative charge without some positive metal ion coming along. So here, if you were to ask to write the product, you would have that oxygen attack where the electrophilic carbon can kick off the bromine. And give you that kind of product there. So there's a way to make an ether molecule. Suppose I gave you that reaction. You draw the product for that substitution. What would you get happening here? OH would substitute for the chlorine. Okay, so I didn't draw the charges here, but you should be able to recognize what the nucleophile is here. Okay. So here, a way to make an alcohol, for example. Okay. Let's look at one more example. Suppose we had something like this. Maybe something a little more challenging. Draw the product for something like that. What would happen?
This
T-butyl with the oxygen,
gonna attach that.
Attack there. yeah. See that? All this other part of the molecule is just coming along for the ride. It's not involved in the chemistry. The chemistry is involved where the leaving group is. All this other stuff is a decoy. Is a decoy. Okay, so you get that. Okay, either. Questions on that? Okay, so this stuff isn't that bad. Okay. So let's call it there for today. I'll got a sheet to hand out to you before you leave.